So, good morning, Professor and everyone from Hebrew Group.
Okay, the name changed from the toilet paper group, right? Into the Papyrus. Okay.
Actually, this is original name.
Original name. Okay, sorry. I will call your group toilet paper group. Okay, sorry.
Let's go to our overview. The project to develop an IoT system designed to monitor the remaining toilet paper in restroom, ensuring both user and cleaning staff are always aware of stock level. The toilet paper monitoring system will use a sensor to measure the distance between the top of the toilet paper roll and top of the corner. As the toilet paper is used, the distance between the sensor and the roll will decrease. Provide the real-time information about how much paper is left, and the data will sent to the M5Stack Atom, where is the calculate the remaining paper on the roll and send it the information via Wi-Fi to local server. For our user story, we have 5. The first one is the device setup and connectivity. As the owner, I want to register my toilet paper monitoring device with my home business Wi-Fi so that I can receive data remotely. Second is toilet paper level detection. I want my device to measure toilet paper level so that I know when I need to refill it. And the third one is low toilet paper notification. And I want to receive a notification when toilet paper is running low so that I can refill it before run out. For refill status monitoring, I want to mark when I have to refill the toilet paper and the system will be tracking. And after that, the staff notification for refill. So the staff member will be responsible to maintenance. I want to receive the notification when the toilet paper is low so that I know when they refill. And next part, I will pass to my team mates.
So we have, can you hear me? You can, right? Okay. So we have our project diagram, which will consist of 2 main parts, the backend and the front end. The backend will have the sensor node sending information to the broker, the database, and then the front end will be getting the REST step and then showing it on the web page. So originally, our data collection will have the sensor ID, which will be the name of each sensor within the toilet, the sensor value, which will be how far it can detect the toilet paper from the top of the toilet paper box. And then from that raw value, we can change it to percentage remaining using this equation as seen here. Next part is the actual implementation of our project. As I previously said, we will have sensor node, which consists of 2 things. We have the M5Stack Atom matrix, which is the small device with 1 big button. And for the distance, we measure using the TOF VL53L0X. So we connect those together, and as we can see from the picture, just assume that the box is the toilet, the big toilet paper compartment, and then we have toilet paper in here. So it have this this sensor node will send information in one of two ways. The first one is that it receives a call from the MQTT, which is sent from the MQTT app. And then the second one is when the reset button is pushed. Well, the reset button means like the big button, but basically it resets the system so when the janitor come in and change the toilet paper, they have to press the reset button to set the max height of the toilet paper. Now it is set this way because we are not sure that the toilet paper will be at the exact same height each time, which is why we have the reset button to do that thing. And the second condition to send the information is when the MQTT calls. So basically we have the server calls instead of periodically sending the information to try and reduce the power consumption of the device. So instead of reading the data every single time it loops through, it can just check MQTT and then delay, check MQTT again, and then delay. Yes. And this is the picture of what it should look like. Also, we decided to use MQTT because the idea is to have this project be installed at locations such as the office where we study. So it will be a big building, and Wi-Fi is probably the best way to send information to the server. Bluetooth is too close. Yeah. And next up will be the MQTT app. As previously mentioned, the data will be sent through MQTT to the MQTT app. The MQTT app's main purpose is to change the raw data into database usable data. Now, as we can see from the picture here, there will be device name, which is sent from the sensor node. So we have to translate that into readable location, as seen in the dictionary here. So we have device 0 to floor 1, room 1, device 2 to floor 1, room 2, for example. The second thing that the MQTT app has to translate is to change from raw data into what we call tissue strength index, the TSI, basically the percentage of how much tissue is left within the tissue box. So here from the top equation, now one notable thing is the capital D, which has to be set manually within this MQTT app. Basically, it's the distance, the total distance from the top of the tissue box to where the tissue is at 0%. Now, we didn't have the reset button there because the M5Stack Atom have only one main usable button, but also we don't really expect the 0% to change all that much, which is why we don't have to constantly pressing the reset button. Yes. And this is what the data will look like before it is sent to the database. We'll have the timestamp, which is collected from the MQTT app, not the sensor node, because the MQTT app should always be running. It's connected to a stationary platform, not in a toilet. So all the device will also sync up to the same time. We'll have the floor data, the room data, the remaining tissue left, and the RST. The RST is the state of the button being pressed. This will be used later on to calculate how much tissue is being used in 1 month. Okay. And also one more thing is that remember the MQTT call to send information to the sensor to run. It is also being controlled from the MQTT app here. So basically, it will send a call every 20 minutes from the time of 6 a.m. to 6 p.m. We set this time range because we assume that it's going to be, like I said, an office building, and maybe the janitor might come in a little bit earlier and leave a little bit later. So we have it like that. And next up is the REST app. The REST app simply take the information from the database and change it into the REST API data. So we did not really change much from the database. We just take it in and then we put it up onto the web UI, which will be the next part.
Okay, thank you. So the next part, this is our framework for our project. At first, we detect the data using the sensor node and send MQTT. Use the MQTT to send the data to the MongoDB cloud server, and then after we store the data in MongoDB cloud server, we fetch the data through the REST API to the web the web app. So for the web app, I have developed the web app based on two aims. The first thing is should be look decent, and the second thing it should be look easier to see the data. So I choose the React.js with white and use the Tailwind CSS to develop the dashboard. Okay, so this is the dashboard for our project. There is the component that I will explain in the next part. Okay, so the first thing is the status card. The status card will display the amount of the sensor node which in any status. Okay, there will be 4 columns. The first column will display the total number of the sensor node. The second column will display the total number of the sensor node that has defined state. I call it defined state. It has enough tissue, something like that. Okay, so it has number in defined state. The third row will be the low state, and the last one will be the danger state that it need to replace the toilet paper as soon as possible. So the next one is the gauge. For the gauge, I have queried the data for each floor and each room. The chart that you've seen in the slide, in the screen, it will display the remaining toilet paper for each room. For this one, I capture from the floor 1, from room 1 to room 5. As you can see, as more as the amount of toilet paper has more, it will increase the gauge bar in the dashboard. And the next part will be the monthly statistic. The monthly statistic will show we have separated into 2 sections. The first section will correct the toilet paper that used in 1 month. It will count based on the reset button that my friend has explained before. It will count like when you press the reset button, this is the time that you replace the toilet paper. And the second one is the statistic that it will show you how that user of the toilet use which room more and less than compared to other room. I think this will useful because if there is the one room that people usually uses more than other room, I think this will be meaningful in some way. Okay, so the next part will be the slide bar navigation. As you can see, I have 3 sidebar objects. So each sidebar will navigate to each page. The first, for the first 4, it will explain the data for the data correct from the first 4. The second 4 will correct from the second 4, and it will be like that. And this part will be the part that I will show you that can you zoom the link, the localhost thing. Okay, as you can see, I'm clicking at the second floor, right? So the part of the website will be like localhost 8000 and for 2 floor. Okay, so the next part will be the video for like the short demo that I have captured from yesterday. Okay, so this is our code, and I run the code from the terminal using the Docker project. So I have some animation. As you can see, it will show the sensor value data differently based on the sensor that is collected data. We fetch this data through the TAIST API from the MongoDB. Okay, for recorrecting, I have misspeaking something before. We didn't use MQTT to send the data to MongoDB, but we use MQTT to send the data from the scanner to the local mosquito and send it to database server later that we use the cloud database. So that is the end of our presentation. Thank you for the attention.